Okay, so this is the final problem for this chapter. The problem statement is we have a piston. This is like this question, exactly the same values, but instead we want to find the acceleration of the piston C. So we have a piston with connecting rod and then with the crankshaft, and it also gave us the angular acceleration of the AB. You can see it is 20 radians per second squared. Determine the acceleration of the piston. And then omega AB and then omega BC are given. And we will use our famous equation. So firstly, we will find the acceleration of B. Why do we find the acceleration of B? Because since we know the acceleration of A, we know the alpha, and then we know the RAB. So these things, RAB, instead I can write this one as B with respect to A. These things will make the solution easier. Okay, and then move C with respect to B. Then find acceleration of C with respect to acceleration of B. Okay, so let's start one by one. The acceleration of B will be equal to the acceleration of A plus the alpha cross the position of B with respect to A minus the omega squared, and then position of B with respect to A. First thing, acceleration of A is 0. Fix it. Okay, it can't move. It cannot, it is fixed. That is 0. And alpha, it is given, it is as 20 radians per second. That is negative 20 K. Negative because it is clockwise. So clockwise and therefore negative. Then RB with respect to A. You see this one. And that one, the RB with respect to A, that is A, that is B, and this one is RB with respect to A. It will have two components. One will be the Y component, the one will be the X component. And then we have 45 degrees. And this one is 0.25 feet. Okay, this will be 0.25 cosine 45. This will be 0.25 sine 45. Okay, and then if you do this calculation, this will be 0.18, and that is 0.18. Okay, therefore RBA will be 0.18. So if I take the coordinate y is this way and x as that way, the x component is negative, so negative I. And then y component is positive, that will be plus 0.18j. And then omega squared, that is given as 10, so squared will be 100. Again, this quantity, it will be that negative 0.18I plus 0.18j. So we will do this calculation, but keep in mind that when we take cross I, then j, and then k. If you take cross of k with I, you will have j, but if I take, you can see here, cross k with respect to j, k with respect to j, that will be negative I. Okay. So with this in mind, then we will get as then A of B will be equal to 3.6I plus 3.6j minus 18j plus 18I. And that will be 21.6I minus 14.4j. That's the acceleration of the B. Now comes the acceleration of c. Again, we will use the same formula, that c will be acceleration of b plus the relative acceleration terms. Acceleration of c will be the acceleration of b plus the alpha cross with r c with respect to b minus the omega squared r c with respect to b. Okay, and then the first term we have found it. This is exactly 21.6 I minus 14.4 j. The alpha term, this is unknown. Alpha unknown. But this alpha is for link BC. Alpha unknown for link BC. Okay. And then RCB. You can see that this is the RC with respect to B. So let's do that now. C and then B. And this one is 0.75 feet. Again, it will have two components. One component will be this way. The other component will be that way. And then the angle is given as 13.6. So this one is 13.6 degrees. Therefore, this will be 0.75 sine 13.6, and this will be 0.75 cosine 13.6. Okay, and then if you do this calculation, that will be that 0.177 I this will be that the j component is 0.73 j. Okay, so we have the r now, that will be 0.177 I plus 0.73 j. So the omega squared, that value, let's check it. It is given as for BC 2.43. So that is 2.43 squared. The RCB is exactly the same as here. So alpha is unknown. So we will assume alpha as alpha k. So it means that alpha is counterclockwise for link BC. If it is wrong, we will get the negative of this one. We don't lose anything. So in that case, if you do the calculation, so you will get that A of C will be equal to 21.6 I minus 14.4 J plus 0.18 alpha J minus 0.73 alpha I minus 1.04 I minus 4.31 J. Okay. You can do this calculation very easily. There is nothing big here, so you just multiply this one with that one, and this one you just multiply with the alpha. As I said, k into, let me see, k into I is j, k into j is negative I. Okay, so this is for the cross product. So you will not, it's not so hard, you can do it easily. Okay, and then let's come back to AC. So you can see that piston is constrained to move up and down. So for AC, piston is okay, so here we assume up, then it will be that AC will be equal to AC and then J. Okay, so if it is wrong again, then it will be that the final result will be negative of this one, and then we will get the negative of this value, so we will correct it.